Back to All Sides with Dan Fisher. If you've ever seen a professional athlete in person, you know that their bodies are usually pretty impressive, very impressive, which makes sense. After all, their bodies are their livelihood. Elite athletes have to be able to run faster, jump higher, throw harder than the rest of us, and naturally it shows. But what is less obvious is that their brains matter too. Still with us is David Epstein, senior writer for Sports Illustrated. His new book is called The Sports Gene, Inside the Science of Extraordinary Athletic Performance. Joining us now to talk more about what we know about the role of the brain is Dr. Jocelyn Faubert. He is director of the Laboratory of Psychophysics and Visual Perception at the University of Montreal. Welcome to the show.
Thank you for having me.
So when it comes to sports, what does it mean to have a better brain? Isn't every brain different?
Yes, every brain is different. But in sports, one of the things that we always wonder is how they can actually process what they have to process in the times that they have to do it in, the decisions that they make on the field, and so on and so forth. So it's very difficult for them to process this high level of input, yet they do it very efficiently. So it's been a wonder for most sports scientists how they can make these fast decisions and make these extraordinary, processing decisions on the field. So for a number of years, people have tried to sort of isolate that and say, well, is there something about their cognitive abilities that they actually do where they're superior to others? And when you've taken them into the laboratory, it's never been really obvious. I mean, there is some evidence that they may be better at some attention tasks or some speed of processing, but it's really moderate compared to what they can do in the field. So in essence, it's been hard to isolate, and people sort of attributed that to expertise level. So learning to be able to do a special kind of task over and over again then makes you so much better at it. Yes, go ahead.
No, but say the special task is, as David Epstein was talking about earlier, watching a ball come at you at 95 miles an hour. How do you teach someone to do that better?
Right. Well, that's sort of what we addressed in our recent studies with the athletes to sort of decipher that issue. We actually developed a task where a complex scene dynamic task. So what that means is you're looking at complex movements and you have to sort of process a lot of things at once, and you have to do this faster and faster. And what was interesting is, of course, we sort of expected that they may be better at doing this task, given that that's a requirement for a lot of the sports activities that they do, that is analyze the scene so efficiently. Mm-hmm. And we did show that for the professional athletes. But what was particularly interesting in that study was that it's not so much where they start, but it's how quickly they learn a new task they've never seen before that corresponds to these things. So they seem to have be much more proficient at learning this complex dynamic scene task.
Does that necessarily mean they'd be good at learning chess and be able to see a chessboard quickly?
Well, chess is not necessarily a complex dynamic scene. It's not a complex scene where you have to track things in movement and so on and so forth. Okay. So it seems like that special ability that they have has to do with dynamics, with things that are moving in complex associations of elements in the scene. So biological motion is a good example of that, for instance. That's a complex dynamic scene. So you can read body movements, and it's really the associations between the different joints and how they move together that you can make some rapid decisions. And that seems to activate a certain center in the brain called the STS, and it has been shown that athletes that are high-level athletes with many years of training actually have thicker zones of the brains that correspond to that. And that same zone is responsible for making social decisions like moving traffic, complex scenes, and so on and so forth. So it seems to be linked with the dynamic capacity. But it also is linked with they can hyper-focus and hyper-concentrate on certain elements in a dynamic scene.
David Epstein, you wrote about this ability. Mm-hmm. Did you what do we know about how that ability or those thicker zones in the brain that you referred to Dr. Flaubert, is something that you're born with versus something that you develop over time. In other words, the whole brain plasticity idea.
Well, I think that's a really complex equation. So, and I tried to do it in a way that I thought people could understand from a hardware and software standpoint. So, what Dr. Flaubert said, I think, jives with a lot of the things I wrote. The ability to look at movement patterns of joints, for example. So, like, I scored faster on a simple visual reaction time test than did Albert Pujols, who's one of the greatest hitters of his generation. And in the first chapter, I describe him being struck out by a softball pitcher, and that's because it's a learned perceptual skill. He's not reacting to the game faster than I am in a brute way. He's learned to see the game and process the game in a different way. And some of those athletes would tell me, some of them I think are starting to know about the science, and that's why they're moving away from using pitching machines, because they realize it doesn't train that same anticipatory skill that they need to predict where the ball is going to go. And with reference to the attention tasks that Dr. Flaubert mentioned, I have a section where I talk about Boris Beck, a study that tracked, among others, Boris Becker and Steffi Graf from the time they were about 12 years old. And Steffi Graf scored the best on everything, whether it was raw athleticism, but they also scored really well in these attention tasks. And it looked like they picked up the sport-specific skills more quickly than did their peers. And so I think there's an interaction of their raw athleticism, their ability to focus and to do the kind of practice that matters to encode those skills. And frankly, I think the balance of nature and nurture not only depends on the skill in the sport, but on the athlete as well. So I have a number of examples in the book where athletes get to the same place via very different paths. So I don't think there's one simple answer.
Dr. Flaubert, is there a change in the brain? Do we know about that, whether it changes over time or it's something someone's born with?
Well, I mean, I really like what Mr. Epstein just said, because that's exactly my feeling about and our knowledge now, I think, in regards to the science. It's very hard to separate nature and nurture when it comes to brain function, because one influences the other and vice versa. So you may have a certain capacity to learn faster, which I think is definitely maybe what pushes the very high-level athletes to become better athletes. In other words, they have to be exposed to learn the tasks. But if they learn faster, they actually get more experience and more exposure to these different kinds of stimuli, and so end up having better expertise levels. So they're not separable, really. There could be some predispositions to learn better and faster certain things, the same way there are maybe physical predispositions. We cannot separate that with our study, but what we do show is that definitely when they get all the way to the top, they're actually much better at learning these different tasks, and they are related to attention levels and hyper concentration levels for these very complex scenes.
Yeah, I've always wondered about the playbook deal and everything. And David Epstein, what about this dumb jock stereotype that we have out there? This doesn't sound like we're talking about dumb people.
No, in fact, in the Groningen talent studies, which are the ones I write about, where they track in the Netherlands youth soccer players who are in the professional development pipeline, they actually found that there was some transfer of their skills, what was called self-regulatory behavior, like, to put it, I guess, to simplify it, sort of taking responsibility for your own training, and that transferred to the classroom, and those players often did better than their peers in school. And I think, and I mentioned this in the book, that some of this idea that athletic prowess is somehow on a teeter-totter with intellectual prowess originated in the 1930s when athletic prowess became associated with African Americans, and that it was in part a result of bigotry and never, to my knowledge, a result of serious science.
But because of those stereotypes, do you think that often, just like girls are steered away from the sciences and math traditionally over time, do you think that athletes tend to be steered away from challenging academics because they aren't perceived as able to do it, and or it takes away too much time from training?
I think they're steered away for that reason quite a bit. And I mean, I saw that in college sometimes, sort of suggesting do a different major and things like that. And it takes a lot of time to be really good at multiple things. And so I do think they're sometimes steered away by coaches because the coach's incentive is not to necessarily have them doing something else. So yeah, I do think that's there. And I assume the stereotype can become sort of self-fulfilling at some point, which can be tragic.
Dr. Flaubert, can you tell us more about how you did your study and what exactly people were looking at?
Yes. To address the questions that you're raising, we developed a task where I was a complex dynamic scene task. So it's essentially looking at a bunch of elements or spheres in a 3D environment, and the idea is that here we force people to sort of attend to certain elements. So we index certain elements, and then the index disappears, and all of this starts bouncing. The spheres start bouncing around in an abstract way. Now, what's interesting about this whole task is that there's no sports-specific knowledge here. So one of the things we wanted to do is to separate the specific knowledge that they have evolved over the years for their particular sport. And we tested over 300 people on this task, and we look at their capacity to learn the task. And what we found was, of course, that we had three main sports. We had over 50 players from the EPL, so the English Premiership teams in England. We had another number from a professional rugby league in Europe, and we had some NHL players. And they all pretty well were a similar performance, both level when they start and learning abilities. So they really were put into one group. Then we compared them with 173 NCAA and elite amateur from Olympic training centers in Europe. And they turned out to be not as efficient initially, and they had a learning curve, but it was not as obvious as the professional players. And then we compared them with university students, which of course are not dumb jocks. And they actually started at the same level as the amateurs, but they did not learn as quickly as the elite amateur level, so the NCAA. So clearly we found a very distinct pattern in the learning capacity for this complex dynamic task over time. So it's telling us something about how their brains are better adapted, if you will, at this particular point for learning these complex scenes. And so it starts making sense that this may be one of the main factors that is actually making them having a certain success in these high level sports, other and beyond, obviously, the basic physical abilities.
You know, David Epstein, it really makes me think about if we have these fabulous brains. They're able to do these incredible things. They're able to do them young, quickly, better than people we perceive as smarter. And yet we throw them out on the field with a helmet on their head. And, just the damage is more than just to some guy who has a lot of muscles and it was just muscle bound. It's very sad when I think about how magnificent their brains are.
Yeah, well, speaking of that, to be honest, the portion of the book that I've been, I guess, most hoping that people would pay a little more attention to are some of the genes. I don't recommend genetic screening for athleticism for the most part, but there are some genes known for sort of injury, illness, and death, and one that we've known since the early 90s predisposes people to having Alzheimer's that now appears to be involved in recovery from all manner of brain injury. And, I went around for the book and asked sort of professional football players, would they be interested in such a test? And they said, it wouldn't make me retire, but I wouldn't hide from it. But sort of the consensus of the medical community has been, well, it's risk information, it's hard to communicate, and there's nothing they can do about their DNA, so don't tell them about it. But there are things they can do about their environment, like maybe not play football or take fewer hits in practice. So I just think more people should be aware that we now know there's a gene that predisposes some people to not recovering from brain insult as well as other people.
Well, David Epstein, I want to thank you for joining us today. I've really enjoyed the conversation. Thank you so much.
Pleasure is mine. Thanks for having me.
David Epstein, he's an award-winning senior writer for Sports Illustrated and the author of a new book on the topic of the sports gene. It's called The Sports Gene, Inside the Science of Extraordinary Athletic Performance. And also, Dr. Faubert, thank you so much for joining us.
Well, thank you for having me.
Dr. Jocelyn Faubert, he is director of the Laboratory of Psychophysics and Visual Perception at the University of Montreal. Thanks so much for the great questions. Thanks for listening. This is All Sides with Dan Fisher on 89.7 NPR News.